NASA once again astonishes the world by taking the first direct image of a faraway world with its James Webb Space Telescope. Forget about consumer cameras and smartphone photographs. NASA's James Webb Space Telescope is the most spectacular imaging equipment of our time. It has and will continue to provide images of places and planets that we will never be able to visit, as well as phenomena that are hard to imagine. Despite the fact that the James Webb Space Telescope's live launch occurred only a few months ago, we've already seen some pioneering and breathtakingly stunning images. Now, for the first time ever, astronomers have been able to use the telescope to capture an image of a planet outside our solar system. Stay with us until the end as we dive into the details of these stunning images. The James Webb Space Telescope is proving its potential to revolutionize exoplanet research. The vast majority of exoplanets have only been discovered by brief dips in the brightness of stars they orbit. Only up to 24 have been imaged directly. But that might soon change. The James Webb Space Telescope has given its first direct photo of a planet beyond our solar system, less than 2 months after it began science operations. The image, which was captured using 4 different light filters, demonstrates how Webb's powerful infrared gaze can effortlessly capture worlds outside our solar system, paving the way for future surveys that will reveal more information about exoplanets than ever before. Exoplanets are often only observed inferentially, either by the minor dimming of light caused by their orbit in front of their parent star, or by the slight wobble caused by their gravity tugging on the star. Actually, spotting an exoplanet is significantly more difficult since the star it orbits washes out the comparatively small world. It's like trying to identify a moth fluttering near a streetlight from blocks away, as astronomers frequently describe it. This is a transformative moment, not only for Webb, but also for astronomy generally, said Sasha Hinckley, Associate Professor of Physics and Astronomy at the University of Exeter in the United Kingdom, who led these observations with a large international collaboration. The planet is visible in the image as a tiny speck next to the blazing star. It is a gas giant that orbits the star HIP 65426, which is located 385 light-years from Earth. Webb photographed the exoplanet using its near-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, each of which focuses on a distinct type of infrared light. Taking direct images of exoplanets is tricky because stars are much brighter than planets. This one, HIP 65426b, was only detected due to a combination of factors. First, it is 100 times the distance between the Sun and Earth from its parent star. For comparison, Pluto only orbits 40 Sun-Earth distances from the Sun. Second, HIP 65426b is incredibly enormous, 12 times the size of Jupiter, the largest planet in our solar system. In the near-infrared, HIP 65426b is around 10,000 times fainter than its host star, and a few thousand times fainter in the mid-infrared. Webb, on the other hand, was able to separate the two objects due to its sensitivity. Obtaining this image felt like digging for space treasure, said Aaron Carter, a postdoctoral researcher at the University of California, Santa Cruz, who led the analysis of the images. At first, all I could see was light from the star, but with careful image processing, I was able to remove that light and uncover the planet. The amazing thing about NASA is that it shares its discoveries with the rest of the world, which broadens our understanding of physics and space, providing us with inspiration and a true inspiration for the cosmos in which we live. The image of the exoplanet HIP 65426b released by NASA is really made up of 4 independent camera views. The NIRCam instruments view at different measurements of micrometers. Both NIRCam and MIRI are outfitted with coronagraphs which block the light from the central star. These images look different because of the ways the different Webb instruments capture light. A set of masks within each instrument, called a coronagraph, blocks out the host star's light so that the planet can be seen. The small white star in each image marks the location of the host star HIP 65426, which has been subtracted using the coronagraphs and image processing. The bar shapes in the NIRCam images are artifacts of the telescope's optics, not objects in the scene. It was really impressive how the Webb coronagraphs work to suppress the light of the host star, Hinckley said. Observing the star through 4 different filters, the scientists eventually managed to obtain images that reveal the planet as a small blob of light. The blob shape varies in each image, a byproduct of the telescope's optics, the scientists said in the statement. HIP 65426b is an extremely young planet, only 15 to 20 million years old, compared to Earth's 4.5 billion years. Due to its gaseous nature, it most certainly doesn't host life. Astronomers discovered it in 2017 while operating the SPHERE instrument on the European Southern Observatory Very Large Telescope in Chile, which captured images with a short infrared wavelength of light. James Webb's telescope, on the other hand, employed longer wavelengths, which assists in uncovering ground-based details that ground-based telescopes cannot. There are still many exciting questions that astronomers may want to answer about this planet and the many other planets that Webb will capture in the future, such as their chemical composition and age. Is this the first exoplanet we've seen? No, but it is the first from NASA's James Webb Space Telescope. The first exoplanets were detected using less advanced technologies in the 1990s. Thousands more planets outside our solar system have been discovered since then. So far, 4 different types of exoplanets have been discovered. A gas giant, such as HIP 65426b, is a massive planet comprised primarily of gas. Neptune-like worlds are gaseous worlds the size of Neptune. Super-Earth, a potentially rocky world that is larger than Earth, they may or may not have atmospheres. Terrestrial, a rocky planet beyond the solar system, some of which may have oceans or atmospheres. The discovery of exoplanets has revealed some remarkable and occasionally scary facts about planets in our cosmos, such as HD 189773b, a gas giant 64 light-years away from us, has incredibly high winds and temperatures, causing glass shards to rain. Or K2-18b, which scientists were thrilled about in 2019 when it was announced that water had been discovered in its atmosphere. Unfortunately, it was discovered that K2-18b might be covered in superheated, supercompressed seas where the water exists halfway between liquid and gas, meaning you'd be vaporized if you tried to take a dip. While this is not the first direct image of an exoplanet taken from space, the Hubble Space Telescope has captured direct exoplanet images previously. HIP 65426b points the way forward for Webb's exoplanet exploration. I think what's most exciting is that we've only just begun, said Aaron Carter of the University of California. There are many more images of exoplanets to come that will shape our overall understanding of their physics, chemistry, and formation. We may even discover previously unknown planets too. The same team of astronomers also confirmed the presence of smoke-like silica clouds in the atmosphere of another exoplanet. Long hypothesized, the discovery reported in recent research reveals that an exoplanet dubbed VHS 1256b has a violent and turbulent atmosphere covered with clouds, except that these clouds are formed from smoke-like silicate particles rather than water vapor droplets. A better way to think of these clouds are objects that are made of tiny particles, except that these silicate clouds are made of the same thing that grains of sand are made of, said Sasha Hinckley. Computer models of exoplanet atmospheres have predicted for decades that these smoke-like particles should exist in these atmospheres, but only JWST has the wavelength covered to definitively detect them. In addition to clouds, the researchers discovered carbon dioxide in the atmosphere of VHS 1256b, just days after JWST discovered carbon dioxide for the first time around another exoplanet. This second time was not widely publicized, which helps put these findings into context. JWST is currently being put through its paces as it's used to make the first ever infrared observations of the cosmos, so expect a bunch of firsts in the next few months. For example, they also uncovered a turbulent atmosphere on VHS 1256b. In a calm atmosphere, there is an expected ratio of, say, methane and carbon monoxide, said Hinckley. But in many exoplanet atmospheres, we're finding that this ratio is very skewed, suggesting that there is turbulent vertical mixing in these atmospheres, dredging up carbon dioxide from deep down to mix with the methane higher up in the atmosphere. This discovery of disequilibrium chemistry on a distant exoplanet is in itself a landmark discovery for JWST. The VHS 1256b is a strange place. The planet orbits not one, but two brown dwarf stars that themselves orbit each other. It does not orbit its binary host in a circle, but rather in a highly oval eccentric orbit. It's 72 light-years away in the constellation Corvus. Its mass, which is in the range of 12 to 16 Jupiter masses, that it really might be a potential failed brown dwarf star rather than a planet. Therefore, rather than just calling it a planet, the paper literally refers to it as a planetary mass companion. It is definitely not terrestrial, said Hinckley. It's much more like a gas giant super-Jupiter object. Either way, this object is roughly 360 times our Earth-Sun distance away from its host star, so takes a whopping 17,000 years to orbit. Based on this first data, it appears that the telescope will outperform its expected performance by a factor of 10. At 100 AU from a Sun-like star, it should be able to resolve a planet 1/3 the size of Jupiter. A planet like Neptune should be detectable from a red dwarf from around 100 to 200 AU. Webb should be able to see a planet 5 times the radius of Earth between 0.5 and 2.5 AU in the nearby Alpha Centauri system. It was a rough ride, but all the years of work on the JWST are paying off. How many more exciting discoveries will the JWST make in the coming months? Are you as excited as we are? Please let us know in the comments below.